Welcome. Hope your lunch was good. I feel like I'm kind of like doing like some sort of like mind control of all like the headphones on. Like it feels like I'm in like a weird post-apocalyptic movie, which is fun and new. Today I'm going to be speaking about feature stores and MLOps more broadly, in kind of this new shift that we're having, this new paradigm around GPT. So we're going to cover a lot of stuff today. We're going to talk about feature stores. We're going to talk about embeddings. We're going to talk about vector databases. We'll talk about the history of LLMs. We're going to talk about so many things. Yeah, when you leave today, I hope that you will have kind of a much deeper understanding about all this stuff. There's so much hype right now, as you all probably know. So my goal is to make sure that you have a deep understanding about all this. So who am I? I'm Simba. Hello. Me and my team are all here wearing pink. Our booth is right there. I am the creator of Featureform. Featureform is an open source tool to define, manage, and serve machine learning features. We make machine learning teams better. We allow them to more, in a better way, work with our data, reuse stuff, organize, governance, access control. Everything related to data and machine learning is what we handle. So why am I qualified to talk about this? Actually, a lot of what I did and am building today comes from knowledge from my last company. My last company, we did personalization for companies like Wall Street Journal, Reuters, Surfline was my personal favorite. And in that role, we were building recommender systems that powered over 100 million monthly active users' experiences. It had multiple steps. It was multimodal. We had embeddings. We had traditional features. We kind of did it all. So a lot of the stuff that's kind of become much more, let's say, in vogue as of recent are things that I've kind of been seeing and been working with for many years now. So this is an example of one step. One of the models looks very similar to this. As you can see here, we have traditional features. We have embeddings. We have vector databases in the top left. We kind of have it all. And part of this is to show that there are a lot of, like, we're talking about the post-GPT world. So there are now these ideas of prompts, LLMs, embeddings. And then there's also all the other stuff that we've been doing for years, like the traditional machine learning. And one way to think about all of this is that there's three types of features. There's three things that can go into a model. There are traditional features, which we'll talk about, where we use models like random forest. There are embeddings, which are typically associated with transformers. There are prompts, which is kind of the new thing, which is associated specifically with LLMs. And they don't all live in their own silos. Like in this model that we built, we were using traditional features and embeddings right next to each other. We literally feed embeddings into a deep learning network. Back when we did this, deep learning was cool. Now it's kind of, that's old, it's boring, we're past that. And with things like RAG, you can actually combine embeddings and prompts. So you can see that there are many use cases where we are using these different paradigms together, but there's kind of three modes of thinking. The way you work with traditional features is very different from how you work with embeddings, which is also very different from how you work with prompts. I want to highlight, there's a lot of talk about like AI, LLMs. A lot of people maybe in this group have been working in ML for a long time, and they have maybe like a random forest in production. And there's kind of this question of like, cool, like, is that gone now? Like, are we past that? Is that over? And the answer is it depends. It depends on what you're working on. What we're saying, like we work with large banks, health insurance companies, et cetera, what we're saying is that for use cases like fraud detection, there's so much transactions, so much data, and we need to really deeply understand and be able to explain what's going on. So we're still seeing these traditional models being used, and I expect to see them to be used for the distant future. Like it's really where they shine. On the other end, there's this new style, let's call it kind of co-pilots, like literally GitHub Copilot, and just other types of tools that make people better at their role. And they're typically, these kinds of models, you're typically feeding them prompts. Those are new, and if you were working in a tool that was kind of in that space, the productivity space, let's call it, chances are LLMs will change everything for you. There's this middle layer, which I'm going to talk a lot about, which is where you take embeddings from LLMs or SLMs, which is small language models, things like BERT, where you can actually sprinkle those on top of existing models. We're seeing this a lot, where people are using LLMs and actually putting traditional ML, like a random forest or typically more like a deep net, on top of it. So they're able to use and use all the value of what they have on top of new types of models. So let's talk about feature stores for traditional machine learning first. So this is kind of like how we've always done things, and a lot of the people are probably still working in more traditional models today. So I've been saying feature and feature store. A feature, for those who don't know, a feature is just an input to a model. It's signal that we feed our model. Examples are things like a store's top selling item, a user's favorite song in the last 30 days, average price of all items in the catalog. These are all traditional features. How do we build them? Well, we have data scientists, sometimes teams of data scientists. They work in notebooks or scripts, and they interact with Spark and Redis and all these different pieces of data infrastructure to actually transform this raw data into the actual features that go into the model. And it's kind of, they're the ones doing all of that. So I ran a team, like I mentioned in my last company, I ran a team of data scientists, and this is how they were working. My goal was to make our data science team better, make them work as efficiently and iteratively as possible. The three things I was kind of thinking about, the three dimensions, was velocity, which is kind of how fast does an individual data scientist move, how fast can they iterate. Throughput, which is essentially collaboration. Like if I'm building stuff and someone else on my team could benefit from that, they should have the ability to reuse. This creates kind of that compounding value. We see a lot in software engineering. We don't kind of rebuild every service from scratch every time in every new team. We reuse things. So one thing I thought a lot about was how can we build stronger collaboration in our data science team? And finally, we powered recommenders for some of the biggest websites in the whole world. And I would have nightmares about waking up to we did some crazy thing and the New York Times has some front page about how we who knows what we would have done. So I have a lot more white hair than I would otherwise, and that's from my time having lots of machine learning in production. So these are the things I thought about. I realized that there was two categories of problem. There was a category of problems which I will call the engine problem, which is a problem of how can I manage 10 terabytes of data, or much more than that, honestly, and how do I process that? How do I store it for low latency serving, etc. The other set of problems, and this is actually the set of problems which we found was more painful, was the workflow problems. The workflow problems are things like being able to reuse things, this versioning, all those problems, how it's more about scaling people. How can we get our team to work together like a team, our organization to act like an organization? Do we have data scientists in the crowd? Maybe a few? Does this look familiar? I don't know if you can read it from there, but it's DF Final looking up at DF7, DF8, DF9. If you're a data scientist, you've probably seen something like this before, or you're lying. The other one, and I don't know if this is readable from down there, is you might have features in production. But again, to my data scientist, do you have an untitled 128, the IPy notebook somewhere laying around? Do you have a table in Snowflake called feature table _ v7? Do you have copy feature to redis.shell? And more importantly, where's your feature documentation? Is it there? Do you have any? These are what I saw my team. It wasn't that Spark wasn't good enough or Redis wasn't good enough. It was these workflow problems. And it's funny because they kind of apply everywhere. It's not like a data science specific thing. It's more of a human thing. We're pretty unorganized creatures. And we end up with a ton of these ad hoc jobs. And what we really needed in ourselves was, like I said, a workflow tool, a way for our data scientists to be able to manage their work, version things, have some sort of structure and how they did data science and ML. That's kind of was the genesis of Featureform. The idea is that data scientists could work in their SQL and their notebooks and Python. They interact with the Featureform framework, and Underneath the hood, Featureform is just leveraging Spark, Redis, whatever else, other infrastructure that we had to be able to actually build those features, serve them, etc. So it's kind of this missing layer in the middle that is needed for the data scientists to have that workflow. That's what we do. It's also open source, which I'll get into, but you can look it up on GitHub. Just a quick kind of like, how does it actually look? I've kind of been hand waving at you. You register tables. You'd have, let's say, a SQL transformation here. You'd put in a function. You annotate it. You say, hey, this is a transformation. You can give it a name, a version, an owner. All that stuff is there. You can create a class, like an entity, like user, and associate features and labels and other things of those users, and also register your training sets as well. And finally, the whole point of features and training sets are to be able to serve for, obviously, train your model and serve in production for inference. So I promised to show a little bit of code. I won't spend too much time on it. But like I said, we're open source, and we have people. Our booth is the pink booth, hard to miss. So if you're curious to learn more, happy to share more. Now, everything I've talked about so far for this first half has been pretty heavily focused on the way we've done things before. But things have changed. In case you haven't heard, there's this new thing called GPT, and it's kind of changing how everything works. And specifically, there's these two types of features, which one has existed for a while, but maybe wasn't as mainstream, and another is actually completely new, completely enabled by LLMs. And so those features are embeddings and prompts. Let's talk about embeddings. This is kind of prompts. I think if you use ChatGPT, you kind of get it. Embeddings are these new magical things that just like have kind of come on everyone's radar. An embedding is a vector. Literally, it's a point in space. It's an n-dimensional space, or you can make it in 3D space for fun pictures. It is a holistic representation of anything, really. We would create user embeddings. So I could look at a user's behavior on a website, and I could turn that behavior into a holistic embedding. The value of these embeddings was that they capture, if me and Shab have very similar music taste, in user embedding space, we will be very close to each other. If someone else has very different taste, like let's say me and Shab like rap music, we'll be up here next to each other. And someone else likes rock music, they're down here. Well, actually, you could figure out where blues music should be because it captures all these kind of intricate, holistic views of these complex topics, including music, including images, including a lot of different things. So that's the magic of an embedding. It's a holistic representation. It's literally a vector. It's literally a point in space, but it happens to encode and embed, which is where embedding comes from, this kind of really vague concepts into a dense space that we can actually use for machine learning. And how do we use them? Well, one option is this nearest neighbor search. If you're going on Amazon and it's like, hey, like people who like this also like this, underneath the hood, that's embeddings. We're just figuring out, taking like a user embedding, they can put it against items. It's a little more than that, but really that's the magic of it, is you can build these kind of and understand taste by kind of putting things into vectors. You can also do it with text, so that similar pieces of content can be near each other, and it can understand like words that are the same, but in the different contexts they mean different things. Like it can actually understand that level of things. You can feed these embeddings directly into models. That's one thing we did very often. You can also use them in other situations, which I kind of mentioned earlier. How do you create an embedding? Well, I think this slide speaks for itself, but in case you don't get it, we use a model type called a transformer to do that. It's not the Autobot in the middle, it's the thing on the left. And a very famous model was a model called BERT, which we talk about a lot. It is not a Sesame Street character. It is a model that also kind of looks like that thing on the left. So I've talked about embeddings. What's a prompt? I asked GPT. So in the context of LLMs, a prompt refers to a specific, I'll leave it to you all. Generally what a prompt is something that you feed an LLM, and it takes that prompt and essentially responds again. The whole premise is you ask it something and it gives a response. So that's a prompt. And with things like ChatGPT, there is some level of state so that they also like there's context. Prompts and embeddings are actually cousins. Like on the left here, you can see BERT, which I talked about before, which is a transformer to create embeddings. All the GPT style models are on the right here. They all actually come from these similar concepts, this idea of attention, this idea of a transformer. And so they're actually very different, obviously, but they actually are much more related than maybe perhaps seem on the surface. So all these things exist and are used in different places. There's traditional ML, there's embeddings, there's prompts. And you can combine them, like I said, like you can have traditional features and embeddings and models like this. You can put embeddings and prompts and kind of this models like this where you are grabbing context via a nearest neighbor lookup. You're using the embedding to get the context, feed that to the LLM in the context window, and then ask your prompt. And guess what? In all of these situations, the same DF final style problems come up again and again. You end up with embedding tables and vector databases where it's like embedding underscore v7. You have no lineage. You don't remember how you built it. You can't build it again. All the orchestration, like running things through OpenAI, is all done in such an ad hoc manner. It's the same problems. Like we keep coming up with new technologies, but we have such a hard time solving these workflow problems. We end up with things, like I said, that look like this, like new v2, new maybe old, new don't touch. So we built Featureform and expanded it to work on vector databases like Weaviate and Redis, to work not just with like SQL transformations and PySpark transformations, but also with model transformers, like through Hugging Face and OpenAI. And this is an example, even on the other end, like post-processing features, like taking a comment that someone writes, transforming that into an embedding, using that through that. Featureform acts like this orchestrator and metadata layer that lives across the whole stack from raw data to the embeddings, prompts, and features themselves. It's open source. You can check out the repo. Our table is just like back there. We're pink. It's hard to miss us. We also have Shab up front, our amazing COO, who you can speak with as well. And that's all I have. So thank you. Hope that was useful.